Okay. Well, whenever we look at an algorithm or whenever we look at a computer, actually, the things we have to understand is this. Look at that input. So once we get an input, we need to get we need an input to process it. If you have no input, then how do you process it? So you want to make a milkshake, but you don't have a milk. How can you make a milkshake without a milk? Right? So you need to get some input. Then we need some rules for the milkshake. What do you do with a milkshake? What makes a milkshake a milkshake? Yeah, so there is a milk. There should be a milk. There should be some more ingredients. There should be more ice, I guess, to put in. Then it will become a milkshake, right? Or smoothie. Wait, smoothie. Sorry, smoothie is with an ice and mix the ice, right? And then that is a rule. That is the algorithm. Or making a hamburger. There's a rule. You can't make a hamburger like you make a milkshake, right? You have some set of different rules to make a hamburger, and then different inputs as well. You can't get the banana and then cherry and then strawberry and then put in a bread. That doesn't make you a hamburger, or just put between two ice pieces. So then doesn't make a hamburger for you, right? So this is the different rules. So we need some rules to process it. Then finally, okay, here is your milkshake, here's your hamburger, here's your pizza. And that is the output. This is exactly the same way we describe a computer. Okay, what is a computer? Let's talk. I think you talked about this before, but I've brought you a nice image here. So when we talk about a computer, the computer is this. The computer has an input device. Computer has a CPU, as you see here. CPU is a control unit, the arithmetic logic unit. Then it has a connection with memory, but yes, there's an output. This is computer. Computer is not what you're looking at. Is a class of a computer. Yeah, if we call them a computer, we call them, but they are laptop, maybe they are a PC, maybe they are desktop. Did I say that? So, but when we say computer, is this, we'll look at an input device, a central processing unit, and an output device. That is a computer. So if you look at this term, there are too many other things could be a computer. So, but again, the same way, when we describe an algorithm, is exactly very, very similar. There is no memory in here, but I think you studied the Python. How many lessons you got Python? 1 class, 2 class? One, the first one. So what was the topic? The variables? No. Okay, no problem. Just print. Okay, perfect. No problem, no problem. So anyway, so basically we can now think of that. But maybe when you learn more Python, then we can discuss more about. But now this is the basically. So we need to get some input. We need to process it, and now we need to output. Okay, now next slide. Before we start, we talk about input, but that input must be well defined. Why? It can't be any input. Like, remember the hamburger and the milkshake. They are two different inputs, ingredients, but let's say input that you put in a hamburger, you put in a milkshake. They are totally different to make that the correct algorithm. So that's why we have to define that inputs very well. Okay, but then again, everything should be, all the process, all the list of the things that we will do must be clear, right? And then again, in talk about the algorithm, it is program agnostic, which means all the programming language has this algorithm. There is no language of an algorithm. The algorithm is a method, is a way how you solve a problem. Okay, apart from a programming language. So we can't say that, okay, what algorithm is using, which programming language is algorithm uses? All programming languages that you can create an algorithm. So it's a language agnostic. We can't say that is for a specific language. No, the algorithm is way of solving, okay? So solving methods. Basically, when you come home, when you ring the bell doesn't ring. What happened is a problem. Now there is a problem there. And this is how you think you will fix that is the algorithm. Okay, is the way of fixing, way of solving the problems is algorithm. And we are doing this in our daily life a lot. For example, can't you log in the Zoom account for our lesson? What is the algorithm you follow up? Some of you ask in the chat. Some of you try to click at the link on the top in the Slack. Some of you is bookmark that link on the browser and they do that. Look, different algorithms you have generated, right? Then you follow that algorithm actually, if you can't log in. If that Zoom account doesn't work, what you do is the algorithm actually solving a problem. You're solving a problem, right? Okay, so that's why there is no language involved on that. Well, okay, so if you continue with the outputs should be well-defined as well. So it's not always we like a hamburger that a shop does for us. We go to the shop, we ask for a hamburger, but we didn't like the burger because it's messy, it's dirty, it's not what we expected. The taste is not delicious, not yummy. So that's not a well-defined output. So the output is also important. Well, when we ask a hamburger, the system doesn't bring us to infinite hamburger, so it should be infinite. It should be the one hamburger, and then because you can eat, that's the amount of you can eat, right? So that must, we have the other things that we have to think is the finiteness, and then yes, and then the thing is the feasible. So this is the characteristic of algorithm. Do we have to memorize? Well, I always suggest practice makes it perfect more than memorization. So, but it's all up to you. Everybody learns different way. So this is all up to you, okay? All right, so, well, here is the other tea brewing algorithm. The same thing. So this is a process. We need some inputs. We need a cup. And then we need a tea bag. We need a water, right? We need a kettle. So we need to bring them all together. This is the process. So we need to get some input and then put that in the water. So this is the process. And then after this all, and finally is an output, so we can drink the tea. Well, that's the process. And this is the algorithm again, okay? Basically, this problem solving steps, we can basically say. All right, now in the next presentation, we will basically see three main things we will do while using an algorithm, while we are solving a problem. We do it not only a programming language, we do it in real time, in real life. Well, now I will ask, if you watched that video that I showed at the beginning of the class, this algorithm from the TED Education, it was about the counting the people in the room, yes? Now, I just want to ask you, again, remember what we have talked at the beginning, why we have 10 numbers, because we have 10 fingers. That was your answers, right? So now I just want to ask you, count your fingers from all your fingers. How do you do that? Let's start. Who wants to just unmute and then Betül,
One
would you like?
one, sorry, sure. We count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, wait, it's easy, yes, but what about these three things? Which one did you use? Or let's talk about the sequencing. So we have some sequencing, which means we do something after the first one, and then next one, and then next one, and then next one. It's just basically sequence, right? It seems we just sequence. So we look at our fingers, and then we just look the first one and second one and third one. So we basically do that by sequencing. Okay, acceptable. What about this one? Saying something true, false. Betül, are you here? Was that Betül?
Yes, I am still here.
Yeah. Well, what about these things like true, false? What do you think what it is?
I mean, if you're asking me about the video, I was thinking there were people in the room. In order to count them, we could either use the n+1, or we could pair them. But when we pair them, we could have odd number of people. So we had to have two options for them.
Nice.
Yeah, that was the one.
Okay, great, great. Rabia, would you like to say anything?
No.
No. Okay, I've seen your mic
I
is on.
want to say something.
Yes, Sophie, please.
Yeah, the idea I have by looking the picture, I'm thinking about to put a light up, on and off.
Hmm.
On maybe is a one game. I'm
Mhm.
suppose if we are putting in on, it's gonna be true, and
Mhm.
the game now gonna be play. Maybe to put line in all the pieces of the of the picture.
Let me. Yes.
That is that. I've just made a description of the picture. If you are putting on, the thing gonna be play, it's gonna be true. If you are putting off, it's gonna be first, and everything gonna be start. That's what that the idea I get.
Yes, nice, nice. How is there any other idea?
I think according to that video, if we count the people, first check if there's a people in the room or not. After that, we can count it.
What else?
To save time, we can find shorter ways of doing those, solving those problems.
If I would say to you, count me up to 5, what would you do?
We can do by twos, or like Sevda said.
Well, just one by one. 1, 2, 3, 4, 5. Why did we stop at 5? How do we know it's 5? Why we did stop there?
We should check before 1, I mean 4,
Yeah.
and check 6,
Yeah.
and we should check middle.
Yeah, so this could be maybe this one, isn't it? Like checked. Is it 5? Did I reach 5? True. So stop. If not, continue. Next one. And then is it 5? Not yet. Then continue. But then what about this? It's like repetition. It's like looping. And you will all see it is in the Python, by the way. But it's now it's good to know before Python. So you will basically recall this point once you learn in the Python. So if we check 5 every time, do we check? Did we reach to 5 every time? Like I count 1. I'm checking. Is it still 5? No, it's not 5. So then 2. Is it 5? No. 3. Is it 5? No. 4 and 5. Oh yes, it's 5. Now stop. That's looping. Actually, you check like if I reached somewhere, but in a loop. So while I'm counting, I'm checking and I'm increasing by 1 every time, and I'm checking if it is 5, then stop. If it is not 5, then still continue the loop through and still count. Okay. Another example. You like tea with sugar. How much sugar you put in? Or let's say count with a spoon. How many teaspoons would you put some sugar? Let's say 3. Is it always 3, by the way? Does it sometimes 4? Does it sometimes 2? Does it depends on how sweet is the sugar? Because not every sugar is the same sweet. So how about eating? While eating, is that exact amount you feel full and you stop eating, or you do eat, you continually eat in a loop until you feel yourself full? So there is no exact stopping point, but you always check your feelings if you are done, but it's in a loop. Okay, what is not in a loop? So this is loop. What is not in a loop? You look out of the window and you are about to go outside, and then, oh, there are some clouds out there, and then it's a little bit overcast. What would you do? Bring an umbrella. You take an umbrella with you, yeah? So because it's overcast, it may rain. So there's true or false. So if it was sunny, then it's not going to rain. So you don't have to take an umbrella. So basically one condition, and you don't repeat this. Okay, but the next one, so this one is in a repetition, like you are eating some food. or you're just putting some sugar or salt to your soup if you use salt. Okay, so that's the loops. And basically, these are the things what we do in programming. Basically, it's the main picture. Yes, there are details, but this is the main picture. Many of the developers of the day and successful developers are just started with this 3 basic knowledge. Sequencing. Do these things in an order, like you prepare a hamburger. You get a bun, you put some patty on it, and then just some salad, sauce, and another bun. Here is the sequence, right, for making a hamburger or again a milkshake. So it's sequence. But again, the true and false, you return that hamburger to the person who asks for, he didn't like or not, false, didn't like. Then he or she brought this back to you. No, I didn't like the taste of it. What would you do? Then you prepare again, I guess, and then bring that back again. Okay, then what about the repetition? While you're eating, you eat, you get some bite, another bite, until you get full, right? You check yourself. Once you finish the hamburger, you check yourself. Am I full? Not yet. So order again. Basically, after a repetition of eating, you check, am I full? Not yet. The order again. Go to the counter, or like a kiosk machine, they put the order that you want, pay the money, and then wait. It's the sequence, basically, in a restaurant. I hope that clears and makes sense. Or the shapes. Oh yeah, good question. Good question. We usually use shapes. I think this is more about in like when you come into the like in more details. Yes, the shapes are the actions, let's say, or functions, let's say. Do a thing, let's say. So you do one step. So do something. Like I said, go to the counter, give an order. So it's like a functional thing. So just to do one thing. When we come to that diagonal shape, it is basically checking a condition. If something is true, it's like raining or not. If that is true, then do this. If not, do that. And the circle ones means end the process, basically. And this is the same thing, but it's represent for the loop until you this condition. So because we said the diagonal shape is for condition usually in when we are using it, mocking up an algorithm actually with the shapes. So we use diagonal shape for conditionals, and we put a condition there, like, did I reach 5? Because I'm counting 5. Okay, so am I full? I'm checking if I'm full while eating. So that's the condition. So I'm asking a question here. We'll come to, I guess, this point now in the next one. Look here, that's one. Like the friendship algorithm from the Big Bang Theory. All right, so let's look at this a little bit. So you will get the point a little bit more about the shapes, right? And yeah, all right, look at this. Place a phone call to a friend, to calling a home. And then is he or she at home? No. Then most probably there will be a message come up, and then you will leave a message there and then wait for a callback. Well, if home, then would you like to share a meal? So that is the question you put in. Now the shape is a little changed. Anyway, so then let's just get down. If yes, so waiting for the response here now. Is it yes or no? After this question, you placed a question now. Now waiting for a yes or no. If yes, then dine together. If not, then do you enjoy a hot beverage? Because not a meal, but maybe a beverage, maybe you can drink something. Yes, so then you put another question, again, waiting an answer. If that question was yes, so okay, your friendship has started. Now you go to and you dine together. Nice. But what if the no? What if the answer is no? Why, if he doesn't want to eat anything or just a meal, but then maybe drink something, then check what is the response again, like a condition. What is the condition here? Again, the Python, you will do this a lot. You will check this again. What is the response? Yes or no? Waiting for the answers. We have two choices. It's like a switch, like Sophie said. So we're waiting for the answer. If the answer is yes, there might be some more cases, like because the beverage, like tea, coffee, cocoa, then, all right, so check for the case and do the things, depends on this case. If the case is tea, then let's have a tea. Let's coffee, have a coffee. Cocoa, have a cocoa. So then, yes, you begin your friendship. But what about, yeah, didn't give up. And what about no? Then, oh, let's go there. Let's start from 0. So this is the input, by the way. So we are always looking for input. Yeah, this is 0 is our input first. Then start from the 0. Do you ask the question again and find it interesting and do again, and increase the number? But then after the maybe 6 times, oh, it's too late. It's 6 times I tried. I didn't get your interest anymore. Yeah, you get tired anyway. So this is the repetition, as you see here. Every time you ask, you try to find an interest, and then until you got the answer yes, you try. How many times? 6 times, almost. Starting from 0 until 6. You try 6 times. And did you reach the 6 times? Yes. If no, then loop again. Do it again. Like if are you still hungry? Just to bite one more time. If you're still hungry, just get one more bite. And then if that is reached, then choose least, I can't read this, but objectionable interest. Then, oh, I can't read this one. Oops. Doesn't repeat. Anyway, yeah, here's the part. Yeah, partake in interest, and then you begin a friendship. But finally, you're trying to end up with a friendship. So that's the something from a real world, actually. We tried. And then conditionals, again, some sequencing, again, there's a sequence here. There's conditionals, there are repetitions here. The 3 things mostly we use when we solve an algorithm. Okay. Sometimes when you go to an interview, if the people you'll possibly be asked about what is the latest problem you solved, but from your real world example, not coding problems. They ask you how you solve a real world problems sometimes. And then now I'm asking you, what was the latest problem you solved in your life? Not, of course, not personal maybe, but that you feel you can share. Maybe fixing electricity problem, fixing some other things. What was the thing? You don't have to answer, think about it. And if you want, you can. What was the last problem you have solved in your life? And think about it and just try to, of course, we don't have that much time to draw that in a paper, but that's, I think, give you an idea. So the interviewee sometimes asks that question. Yes, but now you got the point. These are all algorithms. These are all, while you're doing this, now remember this, the schema here, and then like the ifs, the conditionals, the loops, and these are the things. Yeah, like you got that table in. So this physically, this action. Oh, do we have the legs with me? No. Call a friend to bring that legs for me. Maybe I went to there with my friend's car. So that's why that legs is left in the friend's car. So we need to get that. So until you ask your friends to bring that legs to me, the table legs, of course. And then you place it. And is it balanced? No, just change and then just arrange a little bit, one more leg. And then, no, is it balanced? No, is it balanced? No, do it again and again and again. When it's balanced, then, okay, now you can safely use it. So basically, you're doing all these 3 things: sequencing and condition. Like let's get back to one slide. Sequencing is the selection or conditions 1 time only, and you can use this 5 times, 6 times. But if you will do it again, so we put it in a loop actually. 1 condition for 5 times, let's say. So it's another thing to loop until you make it balanced.